I came across this really nice question on Leetcode today, so I decided to document it. The question has 14k likes, so it's a pretty likable question. I guess because of the different approaches that it presents, and overall, it's a pretty good question to solve if you're preparing for interviews. So this question talks about that we are giving a set of cities and n number of cities and m number of flights. So for example, in this case, we have 0, 1, and 2, 3 cities and 3 flights. Each arrow represents or each edge represents a flight. So from 0 to 1, the cost is 100. From 1 to 2, the cost is 100 as well. From 0 to 2, a direct flight costs 500. So what we are trying to do is find the cheapest flights from source to destination with k number of stops. So if one stop is allowed, then the cheapest flight will be 200, which goes from 0 to 1 and 1 to 2. If 0 stops are allowed, then the cheapest flight will be the direct flight, which is from 0 to 2 and 500. We return 500. So for this question, I tried a couple of approaches. One is dynamic programming, where we calculate each possible combination, memorize the result of combinations as we go, and try to reuse them for other computation. Another approach that I used here is Dijkstra's algorithm, which is used for finding shortest path between a source and a destination, or I would say source and all the destination in a directed graph. But in this case, we use a slight variation of Dijkstra's because we want to account for the number of stops and the source and the destination, and find the shortest part between the source and the destination. So for this video, I'll go over the Dijkstra's approach that I used to solve this problem. So the approach is, if you see the Dijkstra's algorithm, at any point of time we have a set of edges that we want to compute, and we compute the lowest edge with the lowest cost first. And what that guarantees us is, as long as we are processing the lowest edge again and again and again, we are guaranteed that if we reach destination, it will be the shortest path. For example, let's see in this case how Dijkstra's algorithm will work is, leaving the value of k aside right now, is if I start at 0, I have 2 edges to process. One from 0 to 1 and another from 0 to 2. I pick up the edge with the least cost, which is 100. Now I have traversed this, so 0 and 1 are in a set. Now because I've traversed this edge, I put in my heap or whatever data structure I'm using, I'll put back the edge that I can process next. So another edge that I can process next is 1 to 2. But the cost here is the sum of cost here from 0 to 1 and 1 to 2. So I put in 200 back in the heap. Now I have choices of, I have to choose between 2 other edges that I can process. So it's this 200 or this 500. So I again pick up the edge with the least cost, which is this 200, and then the destination in this edge is the destination I want to go to. So the 200 is the shortest path. Let's see this as an example through Heap. So what I try to do here is, let's see, we traverse or process source. So in this case it is 0. So what I populate my heap with destination 1, cost 100, and another is destination 2 cost 500. So I can pick up any one of the edges to process. I pick up the edge with the least cost, so we pick this out. Now we have to put back in the heap then all the edges from the destination we currently process. So in this case it was 1 and 100, so we want to put every edge that is going out of 1. So edge that is going out of 1 is going to 2, and the total is 100 plus 100, so 200. Now our heap looks like this. We again pick up the next edge that we want to process, which in this case is 2, 200, and 2 is also our destination, so the cost we return is 200. Now let's bring in the factor of k. Going back to the question, start of the question, this was what our heap looked like when we started. We just processed the source. Now, as both of these are direct flights from source, we put the value of k as 0. Now, imagine a case where k is 1. When we process this node, we process the edge coming out of 1, which is 2, 200, same as we did before, but we increase the stop by 1 because we have this edge defines that we have taken one stop to reach this state. Now suppose k's value is 0. Now in this case we go back to our initial state, which is 1, 100, 0. Now when we process this state or this edge, we see that if I add 2, 201, it is exceeding my value of k, so I never add it, so I skip adding this. Now in this case, the only thing left in the heap is 2, 500, which we process next and return 500. So this is the algorithm that we will be planning to follow in this case. We can work on another example for this particular case. So this is one of the examples that I found interesting. So everything is the same. We have another node here or another city here, which is 3, and this time the source, let's see, the source is 0 and destination is 3. So let's see what our heap looks like. We also want to define k. Let's define k as only 1. So in this case, what our heap will look like first is 1, 100, 0. Now it's 2, 500, 0. Like 1, we can reach 1 at a cost of 100 with 0 stops. We can reach 2 at the cost of 500 with 0 stops. Now we process the least state first, so we process this state first. When we process this, we have to put back the edge going out of 1, which is going to 2, and the total cost is 200, and the number of stops is 1. Because we have still not exceeded the number of stops, we will keep this in the queue. Now this is still the lowest, this edge is still the lowest, so we will process this edge again. Now we want to process every edge going out of 2 because the node we are processing is 2. So it will be 3, then 300, but the stops will be 2. So will we push this into the heap? No, because it has exceeded the amount of stops we can take. So we just remove this from our heap, or not even inserted in a heap. So the next edge we will process is 2 comma 500 comma 0. The edge coming out of 2 is going to 3, and the cost is 500 plus 100 is 600, and the number of stops is 1. Now our heap has only one element, so we process this first. We have to process this. We see 3 is our destination, so we return 600 back. So this is our overall dry run of the algorithm looks like. Let's try to put this into code. So just listing down that we are using, I always get confused regarding the spelling of Dijkstra's. You use Dijkstra's algo variant, and then you use heap and essentially do a BFS using heap. So let's see. So when I was solving this question before, the basic thing that I wanted is to quickly access the number of edges going out of a destination or a city. So even before that, if you go back here, we have in the heap we have to keep a data structure like destination, cost, and k. So I prefer creating a new class to keep such an information in a proper way in the heap. So it's like trip info, and then we can just use the int destination, or should we use dst int cost and the int stops. Let's create a constructor for the trip info. So int dst, int cost, int stops. dst is equals to dst this dot cost equals to. Java is just excellently verbose, so have patience. This is our constructor. What we want to do is construct a map which can, given a city, it gives us all flights flying out of that city. So in this case, let's see. So in this case, let's take a map which has a key of integer and gives us a list of trip infos. So we can call it trip map is equals to new hash map, and okay. So the first thing I want to do is when this function is called is populate my trip map. Populate trip map. It takes it input of flights. So okay, there's no need of the. I just figure it's easy to write code where like populate is initializing the map, because every time we call this function, a new reference of map is created. So let's see, a trip map is equal to new hash map. So for every trip or every flight information, we have flight and flights. So we have for every flight and flights, let's populate the trip map dot get or default okay, let's see get or default. We get the destination. So the flight is as source, destination, and cost. So we find if there's a map already exists for source. If not, we return a new array list, which will act as a key for this particular city. Trips, trip map, trips. Okay, so now when we have it, we do trips dot add. We add new flight, new trip info, and we want destination, which is flight of 1, and then cost, which is typo flight of 2, and initially the stops are 0 because all these are direct flight informations that we are putting in. Trips dot trip map. Let's put this back in trip map. So ideally, if we had already the reference of the map, we would not have to put it again and again. So one way I can initialize all the empty lists first and then just add trips to it, or this way. Either way is fine. So flight of 0, and then we add trips to this. Okay. I just want to see that I've not made any compilation error at this point, so we will quickly run the default test case. I'm just seeing all the private, spelling of private. Okay, yeah, so it compiles perfectly. Now we want to populate this flights information. So let's see, I've already populated the flight information. Now I need to define my heap. In Java, heap is a priority queue. Priority queue. Say heap new priority queue. So we keep all the trip info. So if you see this here, we want to keep all these 3 combinations in the heap, and then keep processing the trip with the lowest cost again and again. So okay, so we have this set. Now Now we want to BFS by finding the smallest trip again and again, but for that we have to initialize our heap first. So it's just say setup BFS. What we do here is heap dot add all so we add all, so we add all the arrows going out of source. So we do trip map dot get, or just in case we also return a default to cover any weird cases that there is no trip going out of the source. So the source is flight of not flight, sources source, and if nothing exists, return new array. Not new array, let's use the same constant again. Collections dot empty list. Okay, now we have initialized the heap and we are ready to start the BFS. So let's say start BFS. While BFS has a simple while loop where process not heap dot is empty, we keep on processing it. So we want to put in our base condition first. So yeah, first thing first, we find, okay, so we miss a thing. We want to sort our heap in ascending order. So the priority queue constructor is like give it some capacity. So in worst case we have all the flight paths in it, so I will say flights dot length, and then we put in a comparator. So a comparator is for every 2 element. So rule of thumb, where if you want to do ascending we do a minus b, if you want to do descending we do b minus a, the reverse order. So I want to do ascending, so it's a minus a of cost, and we want to sort on the basis of cost. So a of cost minus cost of a minus cost of b. So this should do it. Now we want trip information with the lowest cost. Trip info is lowest, and we do heap dot poll, poll gives us the element and also removes it from the heap. So we have this. Let's put in our base condition. So our base condition is that if we have already reached the destination, that means we have found the shortest path. So we put in lowest dot dst, double is equals to dst, then return lowest dot cost. Our base condition is already set in. Now if that is not the case, let's fan out. We have pulled out the lowest edge. Now we want to put back in all the edges coming out of the destination of the lowest edge. So what we do is find all the, so let's see, for flights, not flights, we want to do trip info for all trip infos in trip map. Let's see, trip for all the trip infos in trip map. Trip map for or default. I prefer to use or default in case, just in case we don't want any nulls or empties. So trip info, we want everything for the destination, not the destination, lowest dot dst, the node we have reached. And if there is nothing, so note that collections.empty-list returns an immutable list, so it should be only used for iteration. So that's why I've used arrays list here and collections.empty-list here. So I return an empty list if it does not exist, otherwise this blah. Now what we do here is heap.add. What do we add is the new destination, which is so first of all, we add new trip info. Now what is the destination? It's the destination of the trip, so dst, trip.dst. Then what is the cost? We want to add the cost of the previous edge to this edge, or all the edges coming out of one here. So it will be lowest dot cost plus trip dot cost. Lowest dot cost, trip dot costs. And we want to put in the number of stops. So the number of stops it took us to go to lowest and then +1. So it will be lowest +1 dot stops +1. Okay, this sounds good. Yeah. Add all the flights from cheapest destination. Let's see if it compiles. Okay, it compiles and it gives us the right result. Let's check. Oh, we haven't added any checks for the number of stops here, so this should actually still give us 200. So we don't want to add any flights if we have already reached k number of stops. So we do if lowest dot stops double is equals to k, then we continue, process the next lowest route. So this is it. Number of stops check. Okay, this looks good. This should fix our problem. Okay, so this should be a good working solution. Just to quickly go over, we can quickly go over the time complexity of this solution. Let's say time complexity. While calculating time complexity, I prefer to go over method by method. So in this approach, although we should have talked about time complexity before getting into the solution, but yeah, let's cut me some slack for this time. So for populate trip map, We are traversing through all the flights and adding it to a list. O1, 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 and this is asymptotically O1, so it's just traversing number of flights. Number of flights is by m flights, so O of m. Now priority queue building, we build a priority queue or heap. Building heap is building heap is O of v, but I don't know in this what in this case what it is, but we anyway have an O of v element. For an empty priority queue, I don't know what the complexity is, but assuming that build heap takes us the amount of, so build heap is on, so in this case we take all the edges. All the edges is all the edges, that means all the flights in this case. Let's keep it on. Where did I type? Okay, so let's keep it as om. Add, so adding takes log of m, so log of m, log of log m of log m. Let's keep it this way. Now for the heap to be empty, we process all the edges, all the trips, so let's keep it O of m. Then we poll, that means we fetch and remove. This is O of m into log, this is O of log m. Yeah, so okay, we are on the right track here. So we, for worst case, we do not account for this. We are doing everything for everything. For this case, we have a time complexity of, we add all the neighboring nodes. So we have calculated this in the while loop, so we are for all the neighboring nodes we are executing this, but we need to add the time for inserting in a heap, which is O of log m. To make it clear again, we have already considered that we traversed through all the edges when we talked about the if heap is empty. So in this case, the total complexity becomes O of m plus O of m, that is another 2O of m, plus log of plus log plus O of log m. Oh, I think I found something crazy. So if I do this and this, oh, I can type with two cursors. Oh, okay, let's see. And now we have O of m into O of log m and another O of log m, so 2 of O log m. So this is O of m plus log of m plus O of m into this is m log m, so we can just replace it by m log m, m log m, this plus this plus this. We can remove the 2. So if we just consider the worst case, time complexity is just m log m, in my opinion. Please note that this can differ from how people interpret things, but I think m log m, or this, is a good approximation of the time complexity of whatever is happening here. So yeah, this is pretty much it. For the space complexity is just O of m is the number of lights. I can just write that. Space complexity O of